Hi, we're at Electronica 2018. I'm here with Peter from Yelo. Now you've got a new 3D AMI machine, which is behind us. Can you just talk me through it?
Okay, yeah, so this is our conformal coat inspection machine. So it's our 3D AMI-CCI. We're going to use the same machine for multiple purposes, CCI being the primary purpose. We can talk about the other uses later. But 3D AMI is a technology company formed to provide 3D metrology-based measurements for inspection and test. And we're focusing on a conformal coat inspection that is measuring the thickness of conformal coatings. Our expertise is in 3D laser triangulation and confocal laser. So we have a lot of expertise in the measurement techniques using this particular type of instrument. And so our manufacturing partner for the machine is Yelo. And so they've built and designed and done the mechanical design for this machine. So as I say, this machine can be used for many uses. This is the conformal coating inspection machine, but exactly the same hardware can be used for solder paste inspection and for PCBA inspection and even mechanical inspection. We can adapt it for different heights and stuff. So, conformal coating measurement is a requirement. So, conformal coating is there for the reasons for, prevention of water ingress and for tin whiskers and so on, and basically for meeting the IPC 610 standard. So, at the moment, the current technology for testing conformal coat thickness is using kind of a UV trace, which is kind of a go, no go, so you can see if the coating's there or not. And also the other methods are non-automated, so sectioning, which would scrap the board basically, so you'd have to microsection by cutting the board to measure the thickness. The other techniques used are using eddy current to measure the thickness on a single point on the board. For that, you'd need quite a large area of the board, to actually to do the measurement. Also, ultrasonic, which is another technique for use, like a single point on the board. So we skip over the detail on the UV trace and the laser reflection. So our measurement technique is to measure the true 3D profile to a micron resolution across the whole of the board. Micron, yes. Yep. Yeah. So therefore we get the full coverage of the PCBA, including the component legs and the solder joints, and the depth and the coverage of the whole PCBA at a 20 micron XY interval. So it's quite a lot of coverage.
Yes, and I mean that is the actual live board rather than, like you say, a sample of it.
And yes, it's a non-intrusive measurement technique. So we're using lasers. So whereas the current technology to measure it using, say, eddy current, which means placing a sensor on the coating itself and measuring the thickness in certain points of the board. Whereas with our technique of non-intrusive measurement using lasers at a 20 micron, we're measuring all over the board.
And it's a usable board still afterwards, isn't it?
And it's still usable afterwards, yes. Yeah. Whereas, sectioning would render the board useless, destroy the board, Also, we can use the lasers to check prior to the conformal coat placement, check for foreign objects, like any kind of debris on the board that could affect and could make the coating come off in use. So we can look for PCBA, PCB de-lamination, and any other contaminations like grease and glue and other non-visible items that are on the board.
Reduce failure rates drastically.
Drastically reduce failure rates, yes, that's correct, So we've been working with Electroloop as a partner on this, and they've been helping us by providing the materials for doing the trials and the technical help and the samples of different types of coatings that are available. And also they provided like an independent sectioning report to confirm our measurements by getting a board microsectioned, taking the measurements and comparing them with our measurements that we've taken. So one of the trials we did is to prove that that our compensation for board warpage is correct, because we need to take two measurements. We need to measure the board profile before the coating is actually applied.
Right.
To look for foreign object debris and for any other greases and so on that could be present, and then when we measure the second time after the coating's been applied, we need to compensate for any kind of warpage that could have happened due to heat or handling, just differences in the way that the board is applied to the machine. Let's get rid of this. So here's an example of some of the sectioning. This is the sectioning report done by that Electrolube got done, showing the thicknesses of the conformal coat. And here is our non-intrusive laser-based measurement, where we can show the thickness of the coating in a similar region to where it was done in the sectioning, and to prove that the concept and the measurement accuracy
is spot on.
Spot on.
Yeah.
Skip over this one. I switch to the
So this is the actual interface of the machine.
So this is the current interface to the machine, yes. So this has been set up for this particular board type, which is a panelised board of 3x2. So we've got 6 boards on one panel here. And so here we're using the robot to move the lasers into position, and we scan each board individually. And from that we scan before the conformal coating is applied and after the coating is applied. So and the second time, after the coating's been applied, we'll calibrate the measure of the board position in relation to the previous board position to zero out any kind of board warpage or any kind of alignment issues, and then we'll take a difference and calculate the thickness of the conformal coat on a 20 micron grid across the whole of the board. So we'll take so we scan the board after the conformal coat's applied, and then we'll work out the thickness of the coating on a 20 micron grid.
That's it in 3D. Yeah.
So here for the output of the second scan, we can produce a 3D contour map which shows the coating thickness in a color keyed map across the whole of the board. So we can see that typically the coating thickness is around 100 microns thick across the majority of the board, and we can identify by the darker blue colors where the thickness is quite thin, and maybe we need to adjust the program where we apply the coating, maybe improve the results. So,
but the beauty is you can see that at a glance. You know what you're looking at straight away, don't you?
You can see at a glance. You can see where the deficiencies are where we apply the coating. So we're kind of like, most people are looking for a minimum thickness to be applied, and they have certain regions of interest, like around the IC legs, or maybe some places where there shouldn't be any coating for mechanical fixings. So here we can check that all of those apply, and we can apply limits for a production process. So it's a kind of an inline process where we can measure and we can verify and validate that the coating's been applied correctly.
That's fantastic. Well, that's and this is. Have you launched it here, or has it been out for a little while?
This is the first time we've done a live demonstration anywhere really for.
Congratulations.
Yeah. Oh, the product is still under development, but
Right.
this is our first working prototype.
That's fantastic. I mean, you can see straight away the advantage of that, can't you?
So here at the show, we're doing a live demonstration with Electrolube applying a new type of conformal coating with an inline ultraviolet curing of the coating, and then a live measurement of the actual coating itself.
That's fantastic. I mean, you're in one of the busiest halls, it seems, in the whole exhibition here, so you must have got quite
very busy show.
a lot of people coming by. Yeah.
Yes.
Well, congratulations with it, and best of luck with it.
Thank you.
And hope the show goes well for you.
Yes, thank you very much.